Welcome to our channel. Today we're diving into the cosmos to explore the 5 most powerful events in the universe. We're talking about events that make entire galaxies look like fireflies in a hurricane. Buckle up because this is going to be a wild ride through space and time. Imagine a star, much more massive than our sun, reaching the end of its life. It's used up all its fuel, and it can no longer hold itself up against gravity. What happens next is a supernova. The star collapses and rebounds in a massive explosion, blasting out light and a shockwave. For a moment, a supernova can outshine an entire galaxy. Supernovae create heavy elements like iron and gold, scattered throughout the universe. Some twinkling stars might one day erupt, seeding the universe with life's building blocks. If you thought supernovae were extreme, let me introduce you to gamma-ray bursts, or GRBs. These are the most luminous and energetic explosions we've ever detected in the universe, short of the Big Bang itself. Imagine focusing all the energy of the sun into a beam the width of a pencil, and then unleashing it all at once. That's the kind of power we're talking about with GRBs. They're so bright that we can detect them from billions of light years away. Scientists believe that some GRBs are caused by the collapse of massive stars into black holes, while others might be the result of collisions between neutron stars. Whatever the cause, these events are truly awe-inspiring, releasing more energy in a few seconds than our sun will emit over its entire lifetime. And just imagine, these bursts of energy traveling at the speed of light have been cruising through the cosmos for billions of years, carrying with them the secrets of the early universe. Who knows what stories these cosmic messengers hold? Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. When two black holes collide, things get really wild. These collisions warp space-time and send out ripples known as gravitational waves. Predicted by Einstein, these waves are distortions in space and time. Detecting them requires incredibly sensitive instruments, but detect them we have. The first detection in 2016 was monumental, opening a new window into the universe. Chapter 4. Quasars, short for quasi-stellar radio sources, are among the most luminous and distant objects in the known universe. These cosmic powerhouses reside at the centers of galaxies and are fueled by supermassive black holes billions of times more massive than our sun. As gas and dust spiral into these black holes, they heat up to incredible temperatures, releasing an astonishing amount of energy across the electromagnetic spectrum, from radio waves to gamma rays. Imagine a single object shining brighter than hundreds of galaxies combined, visible from across the vastness of space. That's a quasar. They're like cosmic lighthouses, beaming out their signals from the early universe, providing us with glimpses into a time when galaxies were still forming. Studying quasars allows us to probe the conditions in the early universe, understand the evolution of galaxies, and test our models of black hole physics. They're a testament to the incredible power that lurks at the hearts of galaxies. Chapter 5. And finally we arrive at the granddaddy of all cosmic events, the one that started it all, the Big Bang. Now the Big Bang wasn't an explosion in the traditional sense like a supernova or a firecracker going off. It was the expansion of space itself, from an extremely hot, dense state to the vast and ever-expanding cosmos we observe today. Imagine all the matter and energy in the universe squeezed into a volume smaller than an atom. That's the kind of extreme conditions we're talking about in the first moments after the Big Bang. And as the universe expanded and cooled, energy converted into matter, forming the first particles, then atoms, stars, galaxies, and eventually us. The Big Bang is the foundation of our understanding of the universe, explaining the cosmic microwave background radiation, the abundance of light elements, and the large-scale structure of the cosmos. It's a testament to the power of scientific inquiry that we can trace the history of the universe back to its earliest moments. Thanks for watching. If you enjoyed this journey through the universe's most powerful events, don't forget to like, subscribe, and hit the bell icon for more cosmic content. We've explored the explosive death of stars in supernovae, witnessed the mind-boggling energy of gamma-ray bursts, felt the ripples in space-time from black hole mergers, marveled at the brilliance of quasars, and journeyed back to the very beginning of time with the Big Bang. The universe is full of wonders and mysteries waiting to be uncovered, so keep exploring, stay curious, and never stop asking questions about the cosmos. See you next time!